guys, Mr. Riley here with the next section here of Unit 8. We have covered solving equations, one-step equations, two-step equations, and equations with like terms and distributive property. And now we are going to shift over to solving inequalities. First, we need to talk about what inequalities are, and that is what Lesson 8-6 is in your book on page 361. Inequalities are like equations, except instead of equal signs, they have inequality symbols. There are 5 inequality symbols: less than, greater than, less than or equal to, greater than or equal to, and there's one additional one that's not very interesting, but it is nonetheless an inequality symbol. It looks like this, and that is the is not equal to inequality symbol. But we don't really have to do much with that. It's not very interesting. Not yet, anyway. Maybe in Algebra 2. All right, so examples here of writing an inequality. So words can get translated to inequalities when there are various numbers that can be the answer to the question, but they're limited to the maximum number or a minimum number, okay, like these examples here. W is greater than 200, represents the number of water slides in Wisconsin dells. It means there's more than 200 water slides. There could be 300, there could be 210. Any number greater than 200 makes that equation or that inequality true. All right, DVDs cost more than $15. More than $15 means that the price, which you have to define, okay, so in real world problems that we're going to model with an inequality, just like with an equation, define a variable. D is the cost of the DVD in dollars. And so if it costs more than $15, then your inequality is D is greater than 15. D is greater than 15. A dog weighs less than 50 pounds. The dog's weight in pounds is the unknown. I'm going to use P here, but okay. And if the dog is less than 50 pounds, then the inequality for this situation is D is less than 50. Remember, when you're talking about the greater than and less than symbols, if you can't remember, right, the pointy end or the short end is the smaller number, or the alligator eats the bigger number. Those are the two sort of tricks for remembering which symbol means what. All right, so here's some got it's here. Amelia sold more than 40 magazines, and Gino sent less than 35 texts yesterday. Define a variable, and then write an inequality. The unknown here is M, and so M equals magazines. That's defining your variable. And M, if they sold more than 40 magazines, M is greater than 40, greater than 40. Gino sent less than 35 texts. The unknown is the number of texts. Could use N for number of texts if you wanted to. And T, if it's less than 35, T is less than 35. Now, one of the differences in inequalities from equations, there are 3 of them, when you're solving them especially, is that you could change the order of these, okay? So you could write 40 is less than M. That's the same thing, okay? If she sold more than 40 magazines, then 40 is less than the number of magazines that she sold. Every inequality can be switched like that. But unlike equations, when you switch the sides of the inequality, you also have to switch the direction of the inequality sign. That's one of the major differences between inequalities and equations. There are 2 more that we'll get to later. All right, so knowing how to translate words into inequalities is an important, probably one of the more important skills of this lesson here in accelerated math. So when do you use the greater than or less than sign, and when is it greater than or equal to? When does it include the boundary number, okay, the edge of your values? And it depends on the words. Less than or fewer than or is below means it does not include that limit number, and that's just a less than sign. Greater than, more than, exceeds, is above. Those are all do not include that boundary number. You'll see this in some examples, right? So That's why there's no equal to sign as part of these for these words. Now, if it says is less than or equal to, okay, that's obvious that it's less than or equal to. And so the little line underneath really means it includes equal, the two sides of the inequality, okay? But so those two, it less than or equal to, greater than or equal to, that those are pretty obvious, okay? But is no more than means that that top number is the edge of a less than or equal to, right? If something is no more than 10, well, then 10 is okay, but the number has to be less than or equal to 10. Same thing for is no less than, or is at most, or is at least. At most and at least, those include the boundary value. Same thing for is at or below. Like for temperature, the temperature is at or below 32 degrees. 32 degrees is okay, and so are anything less than 32 degrees. That would be a less than or equal to symbol, okay? So these are worth a little bit of practice. There's an example here, page 362. You must be at least 18 years old to vote. So what age can you vote? Well, if we let A equal age by defining a variable for the situation, then A has to be greater than or equal to 18. If you are 18, then you are at least 18 and you can vote. And certainly if you're older than 18. So greater than or equal to. Okay. Now in the got it, of course, they use the same exact words as the example, which bugs me. So we'll give you some extra ones on the next page. But a student must have at least 10 hours of instructor-assisted driving time to pass the course. Okay, this is a requirement to get your driver's license in Connecticut. You have to have at least a certain number of hours of driving school. I'm not sure what the number is. Maybe it's 10. Okay, so what's an inequality that represents this situation? Well, the unknown is the number of hours of driving time. So I'll use H for that. And at least 10 means that H has to be greater than 10 or equal to 10. At least is greater than or equal to. So it must include the equal to sign. All right, here's three more since there weren't any more got it's in the book. A couple additional practice problems. Define a variable and write an inequality. Number one, Ledyard is in the COVID red zone if there are more than 2 new positive cases in a week. This is actually pretty close to true, which is why we can't get out of the red zone, because we keep getting a lot of positive cases right now. Okay, so the unknown, the changing amount here is the number of positive cases. I used P for positive cases. Okay, and they're in the red if there are more than 2. So which symbol are you going to use here? P is greater than 2. If P is 2, it's not more than 2. So that's not part of the inequality. The equal sign is not included. Next one. Water boils when the temperature is at or above 212 degrees Fahrenheit. Defining the variable, there's units in this one, so you must have the units when you define your variable. It's not just temperature. Is it temperature in Kelvin, Celsius, or Fahrenheit? And in this problem, it's in Fahrenheit, so you have to say that when you define the variable. Is in degrees Fahrenheit. You could just say T equals degrees Fahrenheit. That's fine also. Okay, at or above 212. So the temperature, T, must be at, that's equal to, or above. So it's greater than or equal to 212. And the last one here, a flyweight fighter's weight, okay, it's a UFC or boxing or wrestling, okay, so flyweight is a weight class. The flyweight fighter's weight can be at most 112 pounds, at most 112 pounds. So the question is it included or not? Well, first, the variable here is the weight of the fighter, and it is in pounds. You can abbreviate LBS, okay? Or you could just say W equals pounds. That's okay. It has to say pounds, though. It can't just say weight, because it's grams or kilograms or ounces or tons, okay? So you have to give the units. And at most 112 means that the weight has to be less than 112, right? But can it be equal to 112? At most means yes, it does include the boundary of 112. So the person weighs 112 pounds, they're a flyweight, they can fight. If they're over 112 pounds, nope, then they got to go up to the next one, which is like bantamweight or something like that. Okay, so Translating these words, that table on the previous page, very useful to know which inequalities to use for which words. All right, so the second thing that's different about inequalities than equations is that inequalities have more than one solution. In fact, they have an infinite number of solutions, most of them, okay? There are more, right? Any number that makes the inequality true is a solution. So one thing you can be asked to do then is to check if a number is a solution to an inequality, or does it make the inequality true or false? All right. So they'll give you an inequality here, like 2t plus 8 is greater than 7, and a value to substitute in for the variable, -1, and you substitute -1 into the inequality, and you see if it comes out to be true. I do not have the capability to draw this greater than with a question mark on it, so I just put a question mark at the end. You'll see like at the end of this inequality to show that I'm not really sure. So you substitute in, show the substitution step. That's required. Okay, then 2 times -1 is -2 plus 8 is 6. Is 6 greater than 7? No, it is not. The answer then is false. 6 or -1 is not a solution to this inequality. Next example, p minus 42 less than or equal to -2. If p is 40, is that true or false? Well, you put in 40 for p. 40 minus 42 is -2. Is -2 less than or equal to -2? Well, it's equal to -2. So because it includes the equal part, this answer is true. If this inequality sign was just less than, then it would be false. Okay, so that's where you have to be careful. Does it include the equal to part or not? All right, 2 for you to do. 3.9 plus x less than or equal to 12. If you put in x equals 6, is this true? Show the substitution step. 3.9 plus 6, is that less than or equal to 12? I put a question mark at the end here. Is it? No, this is 9.9. And well, yeah, 9.9 is less than 12. So this one is true. Y minus 1/3 less than 1. If y is 4/3, is this one true? So we substitute in 4/3 in for y. 4/3 minus 1/3, is that less than 1? 4/3 minus 1/3 is 3/3. 3/3 equals 1. So I get 1 is less than 1. Is that true? No, it is not, because there's no equal sign in the inequality symbol here. 1 doesn't count. So it is false. Okay, so you kind of see where you have to pay attention here, very close attention to whether the equal sign is included or not. All right, so another thing that helps you visualize inequality answers is graphing the answers on a number line. So instead of doing checks when we solve these, a lot of times we just do a number line graph, okay? And there's 2 rules that you have to remember for graphing inequalities on a number line, okay? So the first one is, if you're going to graph A is greater than 6, you want your arrow, okay, the colored in part of your number line, to cover all of the numbers that make this equation or this inequality true. Okay, so obviously you're going to start at 6, the limit. Is the 6 included in the solution? Well, no, it is not, because there's no equal to sign here. Is 6.1 a solution to this? Yes. 6.01? Yes. 6.000001? Yes, that would be greater than 6 also. So you can see you can get infinitely close to 6, but it can't be 6. And so to show that, we draw an open circle at 6. That means it's every value right up to 6, but not 6 itself. Okay. Then you have to decide, well, is it numbers to the right of 6, bigger than 6, or is it numbers to the left, less than 6? Okay, and the inequality is A is greater than 6, so that means we cover up all of the numbers to the right, because these are all numbers that are greater than 6 that make the inequality true. Okay, example, so there's 3 things to do. You make a dot at the border number, in this case, -1. You decide whether the dot is open if the equal sign is not included, or filled in. If the equal sign is included in your inequality, less than or equal to, like this one, then we use a closed circle. Call that a closed circle. Okay, and that's because the value -1 is included. -0.999999999 right on the right side of this is not included, does not make the inequality true. But the dot, the closed circle, means that 1 is included. Then we want values that are less than or equal. So that means I'm going to cover up or draw my number line on covering all the numbers that are less than -1. Very important also, you have to have an arrow at the end here. If you don't draw the arrow, then that implies that your solution stops, okay, which it doesn't. It goes on forever to infinity, to -infinity in this case, okay, or to infinity in letter A. So you have to draw the arrow. If you do not draw an arrow on your number line, you will lose points. Okay, open dot, not equal to. Closed dot includes the equal to. All right, see if you got it. X is less than 5. Open dot or closed dot at 5. Okay, well, the answer is going to be, this is going to be an open dot because there's no equal to sign. Okay, now when you draw these by hand, okay, you do not have to draw out fancy number lines and list all the numbers on there. Okay, really the best thing, if you write in the number, the boundary number of your inequality and a 0 to show kind of what direction things are in, that's enough. In fact, if you just wrote the boundary, just wrote the 5, really I'm looking for, is the open circle or closed circle correct, and is the arrow going in the correct direction? So X is less than 5 is an open circle at 5, and then covering up numbers that are less than 5. All right, so X is greater than or equal to -2. We're going to start with a dot at -2. Okay, and it's solid dot because it includes the value -2. So it's a closed circle. And is it going to be to the right? We want numbers greater than -2 or less. We want numbers greater than or equal to -2. So the arrow goes to the right. And the last one here, X is greater than 0. Open or closed dot at 0. It's open because 0 is not included. And values greater than 0 means that my arrow is going to go to the right. This is the graph of X is greater than 0. And this arrow covers up every single solution, including 0.000000000, right? Or 1/1,000,000th or whatever. Any positive number here is greater than 0, but not 0 because it doesn't include the equal sign here. All right, well, then we should be able to do these problems backwards also. So if I give you a graph, you ought to be able to write the inequality that matches the graph. You look for the circle. Is it open or closed? And then you look at what direction the arrow is covering. Is it numbers greater than the boundary number or less? So in the example here, it's an open circle at 2, and the arrow covers up numbers bigger than 2. So that's X is greater than 2, not greater than or equal to, because it's an open circle. Got it? What is this one? It's a closed circle. Its value is greater than that value -3. So your inequality is X is greater than or equal to -3. Has to have the equal sign because it's a closed circle. And 5B, going this way means I'm looking for values that are smaller than this -2. And the open circle means it's X is less than -2. Okay? All right, so that's the basics of inequalities. We haven't solved any inequalities here. We've looked at whether a number is a solution or not. We've looked at a way to write the solution on a number line. Okay, those are all important things. But the next piece we need to go to is solving inequalities. Okay, so solving inequalities is very, very similar. We're skipping up now to page 367. Very similar to solving equations. with three important differences. One of them we have already talked about, and that's the fact that there's not one solution. There's an infinite number of solutions. Okay, we'll show you that in a minute. All right, so let's see if we can figure out the other ones. So first, the addition and subtraction properties of inequalities, they work the same as equations. If you add or subtract the same value from both sides of the inequality stays the same. Okay, now it's not a balance now because the numbers are not equal, but their positions, right, they stay the same. If you do the same thing to both sides, the balance does not move. Okay, you're still maintaining the out of Mukabala. Okay, and it doesn't matter whether it's greater than or less than. As long as you do the same thing to both sides, your inequality will remain as an equivalent inequality. So solving an addition inequality like x plus 5 is greater than 12, well, we need to get the x by itself still. That's still the goal, isolate the x. So I got to get rid of this plus 5, and I do that by subtracting 5 from both sides. And I get x now is greater than 7. X is greater than 7. All right, now, so the book does checks here occasionally. All right, I typically do not require you to do a check on inequalities because no matter what numbers you put in here, they might come out true or false, and it doesn't really tell you anything. Okay, I think the best thing to do with inequalities is just kind of mentally check really quick by putting 0 in for the variable, because that should give you math that you can certainly do in your head and see if it's true. So if I put 0 in for x, 0 plus 5 is greater than 12, I should get that that's not true, right? And so if I put in my solution here, is 0 greater than 7? No, it is not. So that makes sense. Okay, my answer is good. All right, here's one. Y plus 10 is less than 3. The first step to solve this inequality, get the y by itself by subtracting 10 from both sides. That gives me a new inequality of y is less than negative 7. Y is less than negative 7. So if I put 0 in here, 0 less than negative 7, that's not true. So if I put 0 in my original equation, it should also be not true. And it is. Okay, 0 doesn't work. That's my little mental check. You don't have to write anything down for the check. It just kind of helps you feel good about your answer. X plus 7 greater than or equal to 10. So notice that I haven't changed the inequality sign. It doesn't move or change. It stays the way it was. And to get x by itself here, I need to get rid of the plus 7. So I'm going to subtract 7 from both sides. You must, just like with equations, show that you are doing the same thing to both sides of the inequality. If you only write 10 minus 7 on your paper, you are going to lose points. That's bad algebra. Maintain the Mukabala. Subtract from both sides the same amount. 10 minus 7 is 3. 7 minus 7 is 0, leaving me with just x, which is what I want. And x is greater than or equal to 3. 0, again, would make this one false. Okay, so that's solving addition or subtraction equations. The same as one-step inequalities, the same as one-step equations. All right, now a lot of times when you solve these, it's helpful to graph your solution on the number line. Okay, so sometimes instead of doing checks, you'll be asked to graph your solution on the number line. So 3 is less than or equal to b minus 1 1/3. Now this problem has the variable on the right side of the inequality. Okay, some people don't like that, and that's okay, but this brings up the second major difference in inequalities and equations. Okay, in an equation, like it says in the sticky here, you can change which is on the right and which is on the left without doing anything else. It doesn't change the problem at all. But in an inequality, if you switch the left and right sides, you also have to flip the inequality symbol. Okay, the 3 is less than b minus 1 1/3. If you switch it around, then 3, the b minus 1 1/3 has to be greater than 3. Okay, otherwise you completely change the problem. All right, so when you switch the sides, which you're allowed to do anytime, but if you switch the sides of an inequality, you have to switch the direction of the inequality sign. So this one, add 1 1/3 to both sides. Okay, that makes this one go. They did this one horizontal. Okay, 3 plus 1 1/3 is 4 1/3. So that's my answer. 4 1/3 is less than or equal to B. A lot of people don't like it like this with the variable on the right side when you give your solution. So you can flip it to B is greater than or equal to 4 1/3. And they tell you to graph it. So you got to put a number line there at 4 1/3, 1/3 of the way between 4 and 5, right? It's closed circle because your inequality includes the equal to, okay? And we're looking for values of B that are greater than 4 1/3. So it's the arrow goes to the right. All right, let's do these got it's 2A and 2B. 3 greater than or equal to G plus 7. First step, subtract 7 from both sides. And I get -4 is greater than or equal to G. And I'm done. G's by itself. I could flip this if I wanted to, which I did incorrectly. I could flip this to G is less than or equal to -4. Right? If I switch the sides of the inequality, I have to switch the direction of the inequality sign. All right, to graph my solution, okay, I'll mark my -4 here, the boundary on my number line. Not too good at drawing with the mouse. Closed circle, because it includes the equal sign. And G values less than -4 means that my arrow goes like this. And if I just do that, I will lose a point, half a point. You must have arrows on the end of your solution number line. Okay, B plus 5/7 is greater than 2. Ooh, fraction. But still just getting B by itself. So subtract 5/7 from both sides. 2 minus 5/7 you ought to be able to do in your head. You don't have to change this to 14/7 and then do 14 minus 5 and get 9/7, right? You should be able to recognize that if you take away 5/7 from 2, you're left with 1, and the 7ths that are left over, that's 1 2/7. Okay, so B is greater than 1 2/7. If you were to do this as an improper fraction, okay, and get your answer of 9/7, okay, graphing 9/7 is not easy to do. So that's why when we're graphing, we always will shift to a mixed number. Okay, when you have to graph a fraction, you don't leave it as an improper fraction, change it to a mixed number. Okay, so it's open circle at 1 2/7. So typically what I will do here is a 1 and a 2 on my number line. And open circle here, 1 2/7, about a quarter of the way, right? A little bit more than a quarter of the way. 2/8 would be a quarter. And then draw my squiggly line. Okay, if you draw your line right on top of your number line, because you have to draw in the number line yourself, make sure it's nice and thick, or you can do squiggly lines or something like that. Okay, just to make sure I know where the solution is and that it's not your number line. There you go. Okay, that is solving inequalities by adding or subtracting. All right, so multiplying and dividing is the next place where things get a little weird. They get very weird with inequalities. And since I'm not feeling all that great, I'm using a video from last year for the multiplication and division part of this topic. So you will shift to another Edpuzzle that is from the 7th grade book to do multiplication and division, which is where the major difference between solving equations and solving inequalities comes up. Okay, and then in class on Tuesday, we will solve two-step inequalities and kind of clean all this stuff up with some practice problems. Also give you some IXLs here to work on these. So that's going to do it, and move on to the next video.